Good morning, everyone, and welcome to our third monthly Ocean Plastics webinars. This morning, we have Professor Peter Ryan, the Director of the Fitzpatrick Institute of African Ornithology at the University of Cape Town. Peter has extensive experience in the field of plastic monitoring, and he's here to tell us about using beach litter to monitor plastic marine pollution. Over to you, Peter.
Thanks very much, and welcome everyone. It's kind of weird talking to an unknown audience, but well, bear with me. So the title of the talk is Bottle Lids in the Lockdown, so hopefully that'll become clear along the way. Let's see. So I'm primarily a birdwatcher, ornithologist, but I got into plastics back in the 1980s because I did my master's degree looking at the impact of plastic ingestion on seabirds. So this is the most polluted bird I saw back in the 1980s, a great shearwater. And already by that stage, about 90% of great shearwaters contained plastic. And I wrote a bunch of papers back in the 1980s on the impacts of plastic on seabirds. And sort of since then, I've tended to work more on managing the problem to some extent. And because I've been doing this for a long time, I was asked to write the introductory chapter to the really nice open access book on marine anthropogenic litter. And one of the points I stress in that chapter is that, you know, we've known for a really long time that there's a problem. I mean, I went to the second and the third International Marine Debris conferences, and already by the mid-1990s, the focus was moving away from, you know, how much of a problem is it, onto more of how can we actually tackle the problem. And so my research over the last 20 years has really focused more on that than delving more into the scope of the problem. And if you want to tackle a marine debris problem, obviously the best thing to do is to tackle the causes rather than the symptoms. And in order to do that, we need to know where it all comes from. And so most of what I'm going to be talking about today is around where the litter comes from. And you might think that we know that, but maybe there'll be a few surprises along the way. So when I started working on plastics, it was still pre-MARPOL Annex 5. So this is a picture on a research ship taken in the 1980s. And as we left the subantarctic research base that we'd been visiting, all of the year's rubbish got turfed over the side. So back in the 70s and the 80s, an awful lot of marine debris came from deliberate dumping from ships. But post 1989 and the implementation of MARPOL Annex 5, banning the dumping of plastics at sea, it's generally been sort of thought that around 80% of litter comes from land. And South Africa is quite a good place to look at where plastic comes from because we're quite isolated from many of the major source areas. So we have quite a large plastic industry in South Africa, but relatively speaking, not a lot of large neighbors producing plastic. But I'm going to start off by going somewhere even more remote than South Africa. So I'll take you into the middle of the South Atlantic to Inaccessible Island, which is halfway between South Africa and Argentina. And this is what it looks like on the beaches there. Most of the marine debris, of which there is a substantial amount, comes from fishing activities or other marine activities. More than 90% of the mass of plastic on the shore comes from offshore sources. So as you move away from continental land masses, it's clear that most of the plastic is not coming from land-based sources. But what about the general waste? And so this is where the bottles story came in, and many of you have probably seen the work that Mael Conan and some colleagues and I did looking at the bottles on Inaccessible. We published it last year in PNAS. And because I've been going to Inaccessible for over 30 years, we were able to show that the fastest rate of increase amongst litter on the island was in drink bottles. And this is underestimating the real increase in drink bottles because they turn over faster than heavier things like floats and fishing crates and things. So bottles currently make up about 1/3 of the standing stock of litter on the island. But when we actually measured what was arriving on the island, almost 3/4 of the litter arriving was bottles. And the nice thing about bottles is that they tell you an awful lot of things about where they come from and how old they are. So if you're fortunate and it's still got a label on, you can be pretty sure where it comes from. But even if it's lost its label, there's information on the neck or the bottom or the lid which you can use to identify where the item comes from. And so we've been doing this for 30 odd years now. And when we first went to the island, most of the litter came from South America, with a smattering from Africa, Asia, and Europe. But as time progressed, the Asian component got larger and larger. And so when we were on the island in 2018, almost 3/4 of the litter came from Asia, and most of that came from China. And the origins from South America could be from drift, because if you release plastic into the sea along the east coast of South America, it ends up in the South Atlantic Gyre, which Inaccessible sits on the edge of. But if you release it from China directly, it's going to go into the North Pacific Gyre. So we wouldn't really expect to find this big increase in Chinese bottles that we've been seeing. And we can confirm that those bottles haven't drifted from China because we can look at their ages. So there's lots of different ways that bottles get marked, and we could have a whole talk about the detective work that goes into working out whether it's a best before date or it's a production date. But you can pretty much get a good idea of how old these things are. If you look at the standing stock on Inaccessible, there's bottles going back 30, 40 years, but most of them are less than 5 years old. But if you look at bottles actually arriving on the island while you're there, very few of them are more than 2 years old. So there's no ways that these things are drifting all the way from East Asia. And so this was sort of the story from the paper in PNAS, saying that we're seeing a big increase in drink bottles, and it's coming from dumping from ships. The shipping route between South America and Asia has increased over the last 20 years or so, and that's what we're seeing here. So you might say, well, that's all well and good. That's just one little island in the middle of nowhere. Maybe we should go look at some other islands, and I'm always up for an adventure to go visit another island. So last year I was fortunate to be able to go to Pitcairn, which is another UK overseas territory, but in the middle of the Pacific, far away from any major shipping lanes. And then we'll also have a quick look at what happens in continental areas, both where there's a lot of shipping around the tip of Africa, and then on the east coast in Kenya, where there's much less shipping activity. But let's first go to Pitcairn, just the most bizarrely isolated place on the planet, pretty much. If this is the Pitcairn-centered view of the world, all you see is ocean. And it's quite famous for Henderson Island. The east beach on Henderson Island is supposedly one of the most polluted beaches in the world, and there is a lot of junk on that beach. But Henderson is just one of 4 islands in the Pitcairn group, and the litter loads on most of the other islands are actually quite modest. And it's a really amazing place to get to. To cut a long story short, if you look at the bottles in Pitcairn, you find that primarily come from Asia, with a chunk from South America, some from Oceania, etc., and remarkably similar to the pattern that we saw on Inaccessible Island. And if you look at the top polluters on Pitcairn, it's the same companies pretty much as we had on Inaccessible. It's just right at the 5th versus the 6th company that it changes between the 2 islands. So it seems that if you go into the middle of the ocean, pretty much anywhere in the Southern Hemisphere at least, you're finding the same major polluters in terms of bottles. What about continental areas? So let's start off in Kenya. Kenya has a huge market for bottled water. I was in Kenya just a year ago doing some work with UNEP, and took a chance to look at the bottles there, and it's really crazy how many bottles there are being used, primarily for water. We sampled at various beaches along the coast in Kenya, got 89 different brands of water bottles from Kenya, so huge diversity, quite hard to keep track of them all. And when you're dealing with a continental system, you have to know what's the local product looks like. So the first thing you need to do is go out and collect a bunch of land-based litter away from beaches to see what are people using, what's imported, what's local, etc. And if we look at the street litter along the coast of Kenya, we see that virtually all of it is manufactured in Kenya, very small proportion of foreign. If we go to the 2 major urban centers on the Kenyan coast, Malindi and Mombasa, we see a slight increase in the proportion of foreign bottles. But as we move away to resort beaches, a little bit away from the urban centers, we start to see a much bigger foreign signal. And by the time we get to remote beaches, the foreign offshore source actually exceeds the local source, despite the fact that there is this huge production of plastic bottles. So overall, most of the bottles come from Kenya, as you might expect, a big chunk from the rest of Africa, mainly from Tanzania, neighboring country to the south. But again, there's a very strong Asian signal and a smattering from everywhere else. And then if we move down to Cape Town, what do we see in the Western Cape of South Africa? Again, the street litter is almost all South African. On the beaches in central Cape Town, we find that it's virtually all South African. But as we move away from Cape Town to more remote beaches, we see an increasing proportion of foreign bottles. And once again, we find that the majority come from South Africa, virtually nothing from the rest of Africa, and Asia, primarily China, making up the majority of the rest. So what do we infer from that? It seems that there's an awful lot of dumping going on illegally from ships, and we need to tackle that. It seems that a lot of that is coming from Asian shipping companies. And we can argue the toss about that. I know some people get upset when I point fingers at Asia, but that's what the data suggests to me at least. So I think we need better enforcement of Annex 5 of MARPOL, and this is best achieved by monitoring waste reception facilities in ports. Obviously, people are working on this, but I don't think that there's perhaps enough focus on this. You know, people are focusing too much perhaps on land-based sources. And that was kind of a nice, neat story, but it kind of, a few odd things started cropping up when I was particularly in Kenya. Most of the data we have come from PET bottles. When we started looking at other types of bottles, particularly high-density polyethylene bottles, we started seeing somewhat different patterns. This is very typical of HDPE bottles in the tropics. You see huge bites from sharks, presumably. Some really significant battering that these bottles take out in the open ocean. And if we look at the ratio of PET to HDPE bottles, in Kenya and South Africa, there's many more Chinese PET bottles than HDPE bottles. But if we look at Indonesia, the pattern's reversed. We find many more HDPE bottles than we find PET bottles, which is kind of intriguing. And this got me thinking, what's the difference? Well, PET bottles sink. And if you doubt this, you could chat to Marcus Ericsson, who floated from California across to Hawaii on his junk boat. A few days after leaving, he had to dismantle his floats, remove the lids from the PET bottles that he'd made them from, empty the water out because they'd all started leaking, and glue the lids back on. So there's no doubt that PET bottles out in the open ocean for long enough do take on water and probably eventually sink. So it's conceivable that HDPE bottles provide a better indicator of long distance drift. And if we look at the major currents in the Indian Ocean, where we've been working in Kenya and South Africa, what we see is that there's a nice big fat current running across just south of the equator, the South Equatorial Current, which hits the East African coast around about Kenya and then feeds down into the Agulhas Current, which washes all the way down the south coast of South Africa, all the way to Cape Town. And where does the South Equatorial Current stem from? It's fed primarily by the Indonesian through flow. And we know that Indonesia is responsible for the second largest amount of land-based plastic in the world, as based on the Jambek estimates. Some 10% of land-based plastics going into the ocean come out of Indonesia. So we'd expect to see a large Indonesian signal in terms of long distance drift of plastics. And this is really driven home when we look at some of the South African data. So if we look at the relative contribution of different regions to the west coast and the southeast coast of South Africa, we find that South America is somewhat more common on the west coast, as you might expect, more close to South America. China, also slightly more on the west coast because it's from ships primarily, which are going around the Cape. And the reason why they're more common on the west coast will become apparent in a minute when you see some of the more Southeast Asian origin countries. India, a slight excess on the east coast, but Indonesia, 13 times more bottles from Indonesia on the east coast than on the west coast. And most of these are HDPE bottles. And this is where the lid story comes in, because lids behave somewhat differently to bottles. Most of the lids on our bottles are made from high density polyethylene, so they don't sink. If we look at the ratio of Chinese to Indonesian bottles arriving in South Africa, there's almost 80 times more Chinese bottles than Indonesian bottles. We very seldom find Indonesian PET bottles. But if we look at the lids, the pattern's completely different. So 30 times more lids from Indonesia than we find bottles. And you can actually see the difference when you go down to the beach and look at lids from different parts of the world. So PET bottles are only telling part of the story. If you want to know about long distance drift, then you need to look at plastic polymers that remain buoyant for a long time. So here's some lids that we found loose on the beach in South Africa from countries where they're primarily coming off ships. And these are what the lids look like that come from Indonesia. And these are all Danone Aqua, but I could put up a bunch of other brands. We've had about 10 different Indonesian bottle brands washing up. And you can see they're just completely trashed by comparison. They've been bitten by fish and not looking very happy. Okay, so that's sort of the first part of the story, the bottles and the lids, which are telling us about offshore sources. But of course, I don't want to leave you with the impression that land-based sources aren't important. Certainly land-based sources are responsible for the majority of plastic along the coast of South Africa and probably around most continental areas in the world. And the reason I can say that is if we look at the distribution of macro litter around the South African coast, what we see are these halos of high concentrations of plastic around the 4 major urban centers. And these occur despite the fact that beach cleaning is concentrated around these urban centers. And so from that, we can infer that most litter must come from local sources, because if it was coming from offshore, we would expect it to be more uniformly distributed along the coast. And a necessary corollary of this is that dispersal at sea is limited. And this applies equally to the data we can show in terms of bottles around the coast as well. If the bottles that were coming out of the urban centers dispersed a long way, we wouldn't see the very strong gradients from local source to offshore source as we moved away from urban source areas. And there's a really nice paper came out last year in the Marine Pollution Bulletin, looking at modeling the distribution of plastics coming out of the 4 or 5 urban centers around the South African coast, using a physical oceanographic model. And they suggest that about 90% of the plastic coming out of the East Coast cities should wash ashore, but only about 20% from Cape Town, because most of it jets off up in the Benguela Current into the Atlantic. But this model released litter about 8 to 10 kilometers offshore. And that's because the nearshore shallow waters are very difficult to model because of the influence of tides and waves and wind. It's a much more dynamic environment and very difficult to predict what actually happens. So I think it's an area where we need more empirical data. So I always love an excuse to go and collect data. So we've been working in False Bay. So this is Cape Town. For those of you who don't recognize it, the Cape Peninsula. Table Bay is where the model release plastics were simulated, but a large proportion of the Cape Town catchment actually drains into False Bay, which is a semi-enclosed bay, and the plastic that goes into False Bay probably does somewhat different things to that released into Table Bay. And we were interested in looking at what happens to plastics coming out of some of the estuaries leading into False Bay, and I just happen to live on the mountainside here overlooking the bay. So it's very convenient for me to do some work here. And this is one of the coastal estuaries called Sandflay, which has a seasonally opening mouth. And it's pretty badly polluted because it drains the Cape Flats, where many people don't have access to curbside litter collection. So there's a lot of informal dumping, and that gets into the canals that lead into this coastal wetland. One of the challenges of working here is that it's quite a popular recreational beach. And as soon as you have lots of people on beaches, it gets messy because you're not sure whether the litter is coming from the people on the beach or whether the people on the beach are removing the litter, because with increasing awareness, that's an ever-increasing problem. So thanks to COVID, we had the opportunity to work on a beach without people. So since the strict lockdown in South Africa at the end of March, beaches have been closed officially, and that was pretty strictly enforced at Muizenberg, at least until the end of May. We got a permit to do some work during this time, made us very unpopular. People saw us on the beaches and got very cross, but it was a wonderful opportunity to be able to collect beach litter without interference from people. And so we collected litter along 2.4 kilometers of the beach for 60 days. And we sampled before the estuary opened and after the estuary mouth was breached ahead of the first winter storm. So this graph is just showing rainfall events. And you can see we had a bit of rain in May, but towards the end of May, we had the first big winter storm, and the council opened the mouth to allow the water to escape. And this is what we saw in terms of litter arrival rates. So you can see there's a lag of a day or so, but pretty much after the first winter storm, we saw a big peak in the amount of litter, and then smaller peaks with subsequent rainfall events. But I think, and just to show you in finer detail, this was not just one type of litter, it was a whole bunch of different types of litter, all showed more or less the same pattern. But what was most interesting to me was looking at how the litter was distributed along the beach. So prior to the estuary being opened, there was really no strong gradient along this beach. If anything, there was more at the western end of the beach, up against the rocky shore, and you can still see a signal of a slight peak towards the western end of the beach. But once the estuary was open, there was this very sharp increase in litter right at the estuary mouth. And about half of the litter stranded within 200 meters of the mouth. Now, obviously, this is a fairly small estuary opening into a broad dissipative beach, so one can't generalize too widely. But I still think it's kind of interesting that most of the litter washed up so close to the river mouth. And we did some experiments that I'm not going to report here, but just to say that a very high proportion of marked litter items also washed up, so between 90 and 100%. So it wasn't as though much was escaping out into the open ocean. So the message from this is that beach cleaning does a lot more than raise awareness. It reduces the mass of plastics, particularly if you focus your efforts around major source areas like river mouths. You can really make quite a significant difference in terms of removing the amount of plastic before it gets out into the ocean. And we've got another paper that's currently under review, but I presented this at the last Marine Debris Conference in San Diego, showing that more than 90% of the mass of plastic on beaches is in the macro fraction that's not buried. So if you look at the number of items, there's absolutely insane numbers of microfibers, most of which are probably not actually synthetic, but be that as it may, we then have quite a lot of microplastics and relatively small proportion of macro litter in terms of numbers. But as soon as you start looking at mass, you get a very different view of the world. So surface macro litter makes up more than 90% of the mass, and that's what's available for people running around picking up litter. And one of the big advantages of removing it on the beaches, of course, is if you leave it there, it's probably going to break down quite quickly in that high energy, high UV environment. And once it breaks down into these kind of sort of meso plastic confetti kind of thing, it's much more difficult to actually deal with than when it's still in the macro size fraction. Of course, it would be much better if we were intercepting it before it even got into the sea. And increasingly, we're starting to look at ways and understanding how much litter is making it down catchments. It seems like probably less than we initially thought, but there's scope definitely to improve. This is not a picture from South Africa. This is actually from the US, showing a large amount of litter coming out of the Tijuana River on the border with Mexico. All of these measures are, of course, stopgaps while we come up with ways to actually tackle the way we deal with plastics as a community. the really lasting solutions shouldn't have any plastic going to waste at all, but that's not the topic of this conversation. So in terms of future research priorities, again, I think we've known that there's been a problem with plastics getting into the ocean for 25 years, and the focus should be on mitigation. From an ecological perspective, I think the main research questions revolve around monitoring, so that we can know if we're actually making a difference. And just a bit of an advert, and there's quite a nice overview paper that we put out in the South African Journal of Science earlier this year, just summarizing what I and the team of authors I worked with think are the most important questions in terms of monitoring, and how to go about monitoring effectively to answer those questions. So the main question to my mind is, we want to know whether the amounts, sources and composition of plastics are changing in the environment, because that's what informs whether we're really making a difference in the way that plastics behave in terms of getting into the environment in the first place. And a strong sub-theme of that paper is that we really need to focus on processes and fluxes. If you just look at standing stocks, it's very easy to get confused. And then finally, what sizes of plastics should we monitor? Obviously, there's a whole spectrum from nano through to mega. And in the last 10 years or so, increasingly people have been concerned about the small size fractions. But I would argue that we really need to focus primarily on larger items. Yes, there's an awful lot of small things, but as I've just shown you, the mass is concentrated in the large things still. In terms of environmental risk, yes, ingestion is probably the largest environmental risk, and that's primarily a problem with small items. Large items typically are more a problem with entanglement. But in terms of ease of sampling, it's much easier to get data on large items. The information on origins is much better, as you can see from what we were able to learn from looking at bottles and lids. It gave us insights that we would never be able to get by working on microplastics. And finally, in terms of ease of mitigation, it's much easier to do something about macroplastics. So my personal perspective is that we should be focusing on macroplastics. And if we can solve the macroplastic problem, then the microplastic problem will take care of itself. So that's my story this morning. I hope it's been interesting, and I look forward to having some lively discussion on what I was talking about. Thanks very much.
Thank you, Peter, for sharing your wealth of knowledge. sli.do, password OPW. So we're just going to go through a few of the questions that have been posed to you via Slido. Apologies if I get the pronunciation of some of your names wrong. I will try my best. Please don't take it personally. So one of the questions that we have from Victor Oning surrounds the estimates of oceanic plastic sources that we have out there. So there's been some estimates made, like you mentioned, the Jambeck paper. And he's asking whether or not we have semi-reliable estimates of the sizes of ocean plastic sources, or is it still too uncertain to judge at the moment?
And I'm not sure what you mean by sizes of sources of ocean plastics. I think we have a semi-reasonable idea of how much plastic is floating around at sea. I think we have a fairly poor idea of how much is on the seabed. And I think we know, or I think our estimates of how much is going into the sea is probably poorer. Is not good, because as I try to point out, the assumption has been that plastic that goes down a river or out of a storm drain into the sea becomes part of the sea. And I'm sort of obviously simplifying here, but I think a very high proportion washes up and is potentially available for easy reclamation at that point. The evidence from South Africa from 3 different lines of estimation all suggest that Jambeck's estimates are inflated. Whether that's a general result for the rest of the world is hard to say, but certainly our estimates are probably of the order of 6 to 10 times less than what the Jambeck estimate is. Yeah, so I don't know whether that really answers the question, but that's what I have to say about it.
Thanks for that. And then another question that we have is from Delphine Lobel. She'd like to know if there's any way to distinguish whether the plastic from the beach cleanups comes from the rivers or whether it's washed up from oceanic sources.
Yeah, so I didn't talk about epibionts. The stuff concentrated around the river mouth is coming out of the coastal wetland because it's got an invasive polychaete worm that produces tubes on some of the plastic. So we can see that, we can use that as a tracer of flay litter. And again, virtually all of the litter with this worm growing on it was concentrated around the river mouth. Whereas if we look at pelagic bryozoa, which are ubiquitous on floating plastic that's been in the sea for a while, we find that those are distributed evenly across the ocean. So they certainly are biotic indicators of how long things have been at sea. Things like bite marks as well are quite distinctive for HDPE. Interestingly, it seems like fish don't really like biting PET, or maybe if they bite it, it sinks, but we very seldom find PET bottles with bite marks.
Thank you for that. That's a very interesting tidbit you added at the end as to whether fish prefer HDPE to PET, which would go into the looking at the impact of plastic pollution on marine life. Another question we have is from Matthias Egger. He says, "Thanks, Peter. What a great talk. Did you also look for clues of origin and age for other types of debris besides bottles and lids?"
Yeah, we have used age for things like best before dates on other food products. They tend to be packaged so things like sweet wrappers, ice cream wrappers often have best before dates, chip packets, crisp packets, but they tend not to be very good at lasting a long time. So I think they're good for fine scale, small dispersal kind of questions, but I don't think that they last terribly long. I mean, the oldest lid we've had now is 27 years old. So lids last a long time, but the much thinner, flexible packaging that makes up the majority of sort of urban street litter just doesn't seem to last long enough to give us any really interesting dates. We very seldom find those lasting more than a year or so.
Thank you for that. Another one's from Eric Van Sibyl. Great talk, Peter. Any thoughts on doing experiments with labeled or tagged bottles to investigate further how they beach? Which I think you do have some thoughts on this.
Hey, Eric, thanks for listening. Yeah, so I got into all sorts of trouble last year for suggesting that we would do some litter trace experiments. And we managed to weather that storm. And since then, we've done a bunch of deployments in various estuaries. So the paper that we're just about to submit on the lockdown experiment, I didn't present it, but we deployed 3 types of marked items. So we do expanded polystyrene, wood, and HDPE. So the densities, very different between those 3. And they show different dispersal patterns, as you might expect. And as I say, we've got really high retention rates. Interestingly, so in the case of sandflay, we did 2 deployments. One was on a falling tide, and everything just washed up right on the beach mouth. But the other one was really interesting because it was on a pushing tide, but we did it with a big front coming through. So there was a very strong offshore wind. And the litter we released right where the estuary goes into the sea. And the litter dispersed into the sea up to a couple of 100 meters. But then it all got pushed with the tide back up the estuary, and about 70% of the blocks were found the following day up to a kilometer inland in reed beds and things. So it's not a one-way street from rivers into the sea. While we were sampling in the estuary, we also found lids from Indonesia, also about a kilometer inland. So we're certainly exporting from the estuary, but the estuary also becomes a local sink. And I don't know whether you've seen the French work in the Seine, where they've been finding bottles trapped in the Seine for sort of 30 years. So really interesting how long some of these things can be retained. Just from our little limited sampling in the Flay system here, we've had things that have been more than 20 years old. And if you compare that to what street litter looks like, street litter is almost invariably less than a year old. Very few old things lying around. They get washed off the streets or cleaned off the streets quite quickly. But it seems that freshwater systems can also be fairly long-term sinks for some of these things.
You've raised a very interesting thing that I had personally considered, the fact that we also have oceanic litter getting pushed upstream, which I don't think receives much focus. Anyway, another question that I had is, how reliable do you think beach surveys are in monitoring abundance? Because you mentioned in your talk that, what you find on the beach is affected by a number of factors, your tides affected, your weather affected. So how reliable is it using this methodology to monitor abundance in the long run?
It depends where your beach is. So I think if your beach is on an uninhabited island, the biggest problem is other people. So if you can exclude people from the equation, then I think beaches can be a really useful tool. Obviously, it depends on your question. If you're interested in what the amount of plastic in the adjacent coastal waters is, then you really need to be looking at accumulation on the finest possible scale. So it's no use, it's not great to look at accumulation over anything more than a couple of days at a time, because there's a whole bunch of dynamics within the beach that start to influence things. If you can be sure that people aren't going to mess with your samples, then you can kind of assume that those effects are sort of more or less constant. But anybody who's worked on beaches will know that beaches are quite dynamic places, and one of the biggest problems you have is with erosion and exhumation of buried litter. So although most of the big things are sitting on the surface, there's a huge amount of plastic sitting in the beach body, generally small things. And if you have a big storm that comes and cuts away the sand, you'll see a huge amount of litter appear, but it's not new litter, it's stuff that's in the beach. And this is another place where aging can actually be really interesting. So we've got some data from one of our bottle monitoring beaches where there's active undercutting going on, and most of the accumulation at a normal beach is of bottles that are relatively young, but at this beach where there's undercutting going on, we're finding bottles 10, 15 years old appearing, and it's because they've been buried in the beach. One of my collaborators in the Eastern Cape's got a great photo of a Malaysian bottle buried about 3 meters down in a sand dune that's been exposed by marine erosion. So you can get stuff buried quite deeply. I forget how old that bottle was, but it wasn't massively old, maybe about 8 or 10 years old. So there's a whole dynamic within beaches, and the only way you can really get around that is to sample at a very fine temporal scale, so that you can then know what's going on. If you leave it for a month between sampling events, there's a good chance that you won't really understand what's happening.
Thank you. And then now we have one from Richard Lord. Excellent presentation. Ample evidence for litter dumping from ships at sea. What strategies to enforce MARPOL and Annex 5 and stop litter dumping at sea? So do you have any strategies for its enforcement?
Yeah, I'm really disappointed that the IMO hasn't kind of picked up on this. So I sent them a preprint of the paper from Inaccessible, and it just went into a black hole. I got no response. So I've been trying to prod people since then. I think we need to get the other papers out showing, so the Kenyan data is just about to come out, and then we need to get the Pitcairn and the South African data published. There certainly are people working on looking at port reception facilities, but I feel that the IMO is not really putting enough emphasis on it. And I think that our data really do point the finger at certain sectors of the merchant marine community that needs to be looked at. Maybe, I come from a seabird bycatch background, putting cameras on vessels to ensure that they don't dump. I mean, there's always ways of circumventing these things, but I think just as an awareness raising mechanism, that's one way to help the problem potentially.
Thank you. And then another one from Ghazali Yosra. Thanks for this opportunity. Well, does the microplastic pollution on beaches come from the ocean or land sources?
Both. And I guess, again, it depends where you are. So I think, close to urban sources. So that map that I showed of macro litter around the South African coast, I could have shown you identical pictures for micro. So there's a lot of it coming from local sources, but it's also being generated on beaches, and it's also drifting long distance. So again, while we were doing our lockdown accumulation stuff, we were getting a really high proportion of sort of meso fragments of the sort of 5 to 20 millimeter size range with bryozoa on that are clearly been coming in with the Agulhas current with onshore winds. So there's a whole mix of sources.
Fair enough. And I'd imagine it also depends what the source of the microplastic is, whether it's fragmentation or it's, the case of the pellets that you'd find washed up from the shipping containers, I'd imagine.
Yeah, so I mean, I think a lot of the pellets are legacy pellets still, and they obviously are still dumped, but the pellets are really long lasting on beaches. So some of our really worst polluted beaches are long-term sinks, so the pellets get moved from the source areas to sink beaches, and I think you go there. We've been going to the same beaches for 30 years, and we're finding probably the same pellets. I think a lot of them have been there a long time. If you actually look at pellets out in the open ocean, they're much less common than they used to be, and we can see that they're proportionally a trivial proportion of what's ingested by turtles and seabirds these days is pellets. So pellets are less of a problem. It's more fragmentation. Secondary microplastics are the majority of the problem these days.
Thank you. Then we have one from Ariana Olivelli. Did you notice any pattern in the spatial distribution of beach debris, which I'd imagine you want to switch it to the slide where you had the lockdown beach surveys? And then just building on that, what do you think are the most important factors that will influence spatial distribution? Because in your case, you only looked at that one estuary, but I'd imagine if I went to another one, I might observe something different.
Yeah, sure. I mean, it's hard to generalize from one. So there's a couple of other studies have looked at river mouths. So there was a nice paper by one of Martin Thiel's students in 2013 in Chile. They looked at the distribution of litter around river mouths on the Chilean coast and found plumes of litter downstream from the mouths at a scale of sort of kilometers. There's a couple of papers by Chung from Hong Kong showing that the western side of Hong Kong is influenced by the Pearl River estuary quite significantly, again at a scale of kilometers. So I think the very fine scale pattern that we're finding for this estuary is indicative of a small estuary in a very wave dominated dissipated beach. If we had a bigger estuary system, I'm sure the plume would be more extensive, but yeah, sorry, I'm kind of waffling a bit here. Apart from the local source issues, there's also a whole lot of dynamics around where things wash up. So longshore drift tends to push things to typically kind of one corner of a beach or another. Lots of work being done on that. I won't attempt to summarize that, but a whole bunch of factors are responsible. I think Eric's paper summarizing the physical factors driving plastics around the ocean is a really good starting point that came out in environmental research letters earlier this year or late last year. So have a look at that for examples of what determines where plastics wash up.
Thank you. And then we have another question from Victor again. At least for South Africa, do you think beach cleanups manage to remove a large fraction of the plastic on the beaches, or is it only a small effect? So I guess it's more about the impact of beach cleanups on the amount of plastic flowing into the ocean.
Yeah, it's kind of hard to say. So we have an extended public works program called Working for the Coast. So teams of people that clean most of the coast these days. Most of the sandy beaches get collected. They don't do a particularly thorough job, but they don't get paid very much either. But I think, the bigger items tend to get removed. So probably a fair amount does get removed. But as I kind of tried to say towards the end, I think, we want to intercept it before it even gets onto the beaches in the first place. And so some other data that I haven't shared in this talk shows that at least in summer, the amount of litter arriving on the Table Bay coastline has decreased dramatically in the last decade. And we think that's due to the installation of litter booms on the Black River and some of the other major polluting rivers leading into Table Bay. So it's not helping in winter because the design of the booms is pretty crappy and they don't retain litter well during high flow conditions. But during summer, when it's not raining much, they seem to be catching a large proportion of litter. And we've seen, like almost an order of magnitude drop in the amount of litter arriving daily on the Table Bay coast. So that's encouraging. I think that there are interventions that we can, relatively simple interventions that we can put in place that can really reduce the amount of plastic coming out of these heavily polluted urban areas.
Thank you. I have a question from Andrew, is whether or not there's some platforms or frameworks that others could also use to collect samples on other beaches and provide data for you or other scientists, of which I believe there's some apps that exist, unless I'm mistaken.
They certainly are. So I've dabbled a little bit with citizen science and getting other people involved with mixed success. The bottle and lid stuff is a little bit of a kind of an esoteric art form rather than a science at this stage. So you kind of, it's a difficult skill to transfer. So I tend to get people to collect all the bottles for me, and then we have a small team of us who are now kind of can recognize bottles in our sleep. But to get to that level, we've looked at literally tens of thousands of bottles, and we're getting the same way with lids now. So it took a while to get to the point where we are. So it's not an easy thing, but there's certainly scope for anybody to do the fine scale stuff. I mean, I think it's a wonderful project for people who care about the coastline and living on the beach and potentially have the time, like retired people, for example, who are going to walk the beach anyway, just to document what washes up every day, even if they don't go into any great detail as to where it comes from or how old it is, but just to document how much stuff arrives. You can really get some useful insights from long-term fine-scale sampling as to what's driving things in terms of rainfall and wind and currents and so on.
Thank you. And then another one is we've seen a lot of photos on the media with all the masks that are now being dumped ending up in the waterways. Did you notice any COVID-related PPE items washing ashore?
Not on the beach. So in tandem with the beach work, we also did some street litter work. So we looked at the impact of the lockdown on the amount of street litter, and big surprise, when we were locked down, there was much less litter. So just drives home that people are the problem. We did that in Durban and in Cape Town. And we certainly found masks, but masks and gloves and lots of wet wipes, because my sample area ran next to a police station. Obviously, the police were given wet wipes, so that was just a mess. But it was still a trivial proportion of the litter stream. It's like 1% by number and 2% by mass, or something like that. So yes, it's a problem, but relative to just the general Cape Town street litter problem, it's relatively trivial.
And then we've got about 10 minutes left, and I have a particularly juicy question that I'd like to ask you from Delphine, because I would like your thoughts on this, because we do have a lot of research happening and everyone is monitoring and coming up with numbers and compositions. But Delphine raises a good question. Have you shared your results with the South African and Kenyan governments? And have they been more open to enforcing local plastic restrictions? So how have your interactions been as a researcher with the powers that be?
Are there powers that be? I've always tried to work with the excuse me, with the plastics industry, and I found the Plastics Federation in South Africa, what's now Plastics SA, has always been very receptive and helpful in terms of trying to take what we found and inform their members, and try to get their members on board. At a government level, I've had less success within South Africa. The Department of Environment Affairs in this country is kind of, I should probably watch what I say on a public forum, but they like to dance to their own tune, and they're not very keen on engaging with other people, perhaps. So they talk the talk, but you don't see a lot of action in terms of on the ground activity. But I think through various regional initiatives like WIOMSA and the Linda Godfrey's waste, can't remember the jargon, but there's a lot of useful initiatives around tackling the waste problem in South Africa in particular, and throughout the Western Indian Ocean in general. So I think the avenues are there for communication. The stuff that I've been talking about today is still very much, as I say, the Kenyan stuff is just, I'm getting the proofs this week for the paper. And the South African bottle data, we've just finished collecting it, so we haven't even written that up yet. You guys have got a sort of sneak preview today. So we'll certainly try to communicate it through as many channels as we can. And yeah, hopefully it'll make a difference.
Thank you for that. And then one last related question before we have to start logging off. There's someone's asking, we're keen to use our Dirty Dozen methodology to drive change and inform policy. Do you have any suggestions as to how we can go about this?
I'll just reiterate what I've just said. If you want to change behavior, that's sort of a sociological question, and I'm an ecologist, so I'm not really the right person to ask these things. So that's why I say from a research perspective, from my personal research, I see my value as informing the mitigation actions, what's working, what's not working. In terms of actually devising mitigation and working with policy and communities to make a difference, that's not my skill set. So I need to work with people like Rini Schenk and that to, they can try to implement the change, and I can tell them whether that change is working or not from the monitoring that we're doing.
Thanks. So it's more of it's not a silo approach. We need to reach out to the people in the different disciplines so we can come together and force change in different areas.
Yeah, absolutely.
And then just to end off, you've been doing this for a very long time, which I feel like doesn't actually capture how long you've been doing this. For the early career researchers out there who are jumping into this exciting field of plastics research, any words of wisdom?
I think for anybody who's starting anything, think, if you're going to be in a place for any length of time, try to set up a long-term study. So rather than sampling widely, sample over time if you can. So as soon as you're in a position where you know you're going to be somewhere for some period of time, then set up something that you can maintain, because we live in a time of unprecedented global change, and long-term data series are incredibly valuable. So the fact that we've been picking up litter on the same way on the same beaches for 30 odd years now, I think that's one of the ways that we've managed to make a bit of an impact, hopefully.
Thank you very much, Peter. Thank you for taking the time to talk to us and for sharing our knowledge with us. Thanks to everyone who joined us on the live stream. As always, our stream will be available afterwards, so you can always come back and refer to it and hear questions. Please share it online, get more publicity for our webinar. We're still young in the webinar world. And that's it from us. Any closing words, Peter?
No, thanks very much for the opportunity. It was kind of daunting, and I'd be interested to know how many people were listening, but yeah, it was fun, I guess.
All right, cheers. Enjoy your day.
Cheers.
Bye, everybody.